In this lecture, we'll continue our discussion of regression plots. So far we have seen that we can change the color of our regression plots by passing the color attributes, but that changes the color of our regression line and also our scatter or data points. There is a method that we can pass to change the color of, let's say, only the regression line or just the scatter points. We'll see how to do that. For that, we'll be passing the line KWS or the scatter KWS attribute, and then we'll pass dictionaries, key and value combinations to change the color of, the attributes of either our regression line or the scatter plots. Let's see an example. We'll use the tips dataset first and see how we can change those attributes. So we have SNS.reg plot, and we have seen this in the previous example. On the x-axis we have total bill, and for our y-axis we'll use tip, and then data comes from the tips dataset. So if you recall, this is what it looks like. What we'll do next is pass the line KWS and scatter KWS attributes to change how this scatter and the line plot appears. Okay, let me copy that, paste it here, and let's pass those attributes. So let's go to a new line and add the scatter underscore KWS attribute, that's the attribute name, and then we'll pass whatever attribute we want to change. We'll pass it as a key and value combination. For instance, we have marker, so if we want to change the marker, we will pass that as a key, and for value, we'll pass the value of our marker. Let's say we want to use a diamond. Okay, we can do that, and then we can pass another key and value combination. Let's say color. So for our color, let's pass blue, for instance, and we'll do the same for the line KWS attribute. Let's go to a new line. So we have line KWS, and for that, for color let's use red, and we can pass the line width attribute also, line width, and let's set the line width to 3.1. we can adjust this by looking at the regression plot. Okay, it looks good now. Let's run it. Nice. So now we have our scatter plots in blue and our line plot here in red, and that's the width. You can adjust the width to a different value. For instance, if I make this 4.5, now we have a thicker regression line. And for our marker, let's use a plus sign. Looks like the marker is still the same. We still have circle for our marker for our scatter plots. What we can do is we can pass the marker attribute here in the regression plot as a separate attribute and set it to, let's say, diamond, and we can remove it from here from our scatter KWS attribute. Okay, let's try it again. I'm missing a comma here. Let's run it again. Okay, now we have diamonds for our marker. Similarly, we can change it to some other marker. Let's look at one other example. Let's change the marker to a plus sign. Let's change the color this time to, let's say, gray, and the color of our line plot to, let's try black, and the line width to 2.5. Run it. Okay, here we have different attributes now. So the color is changed, the width of the line, and let's change the marker to, I guess there is no plus marker. Let's change it to circle. Run it again. Now we have circles. That's how we can control each of our individual plots, either the scatter plot or the line plot. And we can do the same for our other regression plot, the one that we used X value and Y value. Okay, so if I paste it here and change the x-axis to the X value variable that we defined in the previous lecture, and our y-axis to be the Y value variable, we don't need the tips dataset. So marker, we have diamond. For our scatter plot, let's change this to purple, and for our line, let's change it to green, and let's make the line width 1.5 and run it. So here we have a regression plot for our data here. Another thing we can add in our regression plot is we can add the confidence interval value for our standard errors. For that, we'll pass the CI attribute. So for instance, let me copy this, or let's type out a new regression plot, sns.reg plot, and for our x-axis, let's use X value. For our y-axis, we'll use Y value, and then we can add the confidence interval value of, let's say, 34. This will be for the error, for estimating the standard error. Okay, that's what the regression plot looks like. If we copy this, paste it here, and change the confidence interval to a different value, let's say 68. This is the corresponding regression plot, the corresponding line fit. So you can compare this to different confidence interval values. Let's look at another example. This time we'll consider the size and total bill variables from our tips dataset. So sns.reg plot, for our x-axis we'll use size, and for our y-axis we'll use total bill, and our data comes from the tips dataset. So if we run this, we have size on the x-axis, total bill on the y-axis, and we have a regression line here for our data points. So the scatter points for each of the size look like more of a straight line, right? To make it more dispersed, we can add an attribute known as X jitter, and that will make it a bit more dispersed. So it will give us more information about our size attribute, about the size. Let's do that. So add X jitter and set it to, let's say, 0.3, and see what it looks like. Okay, I think that's a bit too much. So if we put this to a higher value, it will make it scattered, and we won't be able to distinguish each of the size. So let's change this to maybe 0.08 and try it. Okay, now it's a bit more scattered compared to our first regression plot here. You see, it looks more of a line. Now it's a bit more scattered, and so you can change this X jitter value to a point where the data will be more scattered, so that we can get more information from our regression plots. Looks much better now, right? You can see that we have customers with a size of 2 the most, right? Whereas customers of size 5 and 6 and 1 are a few. And again, you can apply the line KWS or the scatter KWS methods. For instance, scatter underscore KWS, and you can pass a key and value dictionary to change the attributes. For instance, I can change the color to red and run it. Now we have red scatter plots. Another thing that we can do is pass an attribute known as X estimator, and that will allow us to see the mean of each of the values. Let's see an example. So we have SNS.reg plot, and for our x-axis we have size. For our y-axis we have total bill. Now data comes from the tips dataset, and let's pass the X estimator attribute, estimator, and we'll set it to be equal to the mean. So we'll use NumPy's mean method, and this will allow us to see the mean of each of the sizes. So let's run this. So here we have the mean for each of our sizes. So for our customer size of 2, the mean of the amount paid is about what, 18, 17. For a customer of size 5, the mean of the amount paid is about $30, and this is the confidence interval values. Okay, this line. Great. So this is what I have for the lecture on regression plots. So we have looked at a few attributes. So go through this in the previous lecture and try out different attributes and how you can use those attributes to get more information from our regression plots. So just to summarize, regression plots gives us a best fit line for our scatter plots, and we can pass the line KWS or scatter KWS attributes to change the properties of our scatter plot or line plot. Thank you everyone, and see you at the next lecture.